Hello everyone, myself Dr. Janavi Chakraborty, Department of Mathematics, Assistant Professor, Bardhaman College of Engineering. So in this video, I am going to discuss the solution of algebraic and transcendental equations. So as you can see, the topic is solution of algebraic and transcendental equation. So first of all, we need to know what are algebraic equations. So algebraic equations are those equations that involves number, variables and these arithmetic operations. For example, you can take the polynomial equations here. So one example is given here, that is x cube minus 2x square plus x minus 5 equal to 0. You can take other polynomial equations as well. So the next one is transcendental equation. What are transcendental equation? So transcendental equations are those equations that involves transcendental expressions like logarithmic, then trigonometric, exponential, etc. So for example, we can take e power x minus x square, where exponential function is involved here, and here trigonometric function is involved, that is sin x minus x equal to 0. That is an example of transcendental equation. Okay, now let us look at the definition of zero or root of an equation, be it transcendental or algebraic. So what is a zero or root of an equation? So zero or root of an equation is that particular value for x for which the function gives you 0. Okay, so and that at that value of x, the function intersects the x-axis. So let us see it through an example. So if you take x-axis and y-axis, here x-axis and this is y-axis. So if you take a function f of x equal to x square minus 4. Now you make a table for it. This is x values and this is fx values. So if you take x as minus 2, so you will get here minus 2 square minus 4, this will be 0. If you take minus 1, this will be minus 3. If you put 0, it will give you minus 4. If you put 1, it will give you minus 3, and if you put 2, it will give you 0. So now let us put these values on this graph. So you have minus 1, minus 2, minus 1, minus 2, and this is 1, 2, and here it is minus 1, minus 2, minus 3, minus 4. Okay. So now you put for minus 2, the function value is 0, so this is the function value. For 2, the function value is 0, so this will be the function value. Now for 0, the function value gives you minus 4, so this is the function value. And for 1, what you have? For 1 you have minus 3, and for minus 1 you have minus 3. So now you join these points. Now you join these points, you get this parabola, and look at this function where it cuts. This is y equal to, this is fx equal to x square minus 4 function. So where it cuts in at these 2 points, right, minus 2 and plus 2. So these two are the roots of this function. Okay, this is how we find the roots or 0. Next we will see the intermediate value theorem. So this is the base of all the numerical methods. So this ensures the existence of solutions for solving these equations, algebraic or transcendental. So what it says? It says that if f of x, the function of x, is continuous in some interval, closed interval a comma b, and the f of a and f of b is less than 0, then there is at least one real root or an odd number of real roots of fx equal to 0 in the interval a comma b. Okay. So there exists at least one real root or an odd number of real roots of fx0 in interval a comma b. So now we will discuss what are the methods to find the root of an equations. So here we mentioned 4 methods, that those are bisection method, regular falsy method, fixed point iteration method, and Newton-Raphson method. So here we will discuss first the bisection method. What is bisection method? So bisection method use the intermediate value theorem to find the solution. So this locates the root of the equation fx equal to 0 between a and b. So what is the intermediate value theorem? If fx is continuous between a and b, and if f of a and f of b are of opposite signs, then there is a root between a and b, right? So we consider here first, if let f of a be negative and f of b be positive. Then by bisection method, the first approximation to the root is given by x1 equal to a plus b by 2. Now we need to find the function value at this x1. So if the function value at this x1, if it is 0, then the x1, we say that x1 is a root of fx equal to 0. Okay? Then if this is not 0, if fx is positive, if f of x1 is positive, so what we get? So we get that the root lie between a and x1, because see, f of a be negative and here f of x1 is positive. By intermediate value theorem, we get that a root lie between. So if f of a and f of b are of opposite signs, then there exists a root. Now we see that here f of a is negative and f of x1 is positive. So a root lie between a and x1. So what is the second approximation will be? The second approximation by bisection method, that will be given by this x2, that will be the average of this a plus x1 by 2. Next, so now we will check what is f of x2. So if f of x2 is now negative, if f of x2 is negative, then the root will lie between x1 and x2, because we are considering f of x1 is positive, right, and f of x2 is negative. So root will be lie between x1 and x2. So what will be the third approximation? So the third approximation to the root will be the average of x1 and x2, that is given by x1 plus x2 by 2, and so on. We will repeat the process. Now let us look at the example. Now let us look at this problem on bisection method. So what is given here? Let the equation is given here. So you will let it as f of x equal to x cube minus 4x minus 9. Okay. So what we have? We have, now you prepare a table on this. This is x values, this is f of x values. So what are x values? This is minus 1, 0, 1, 2 and 3. You can take x values as like this. So for minus 1, what you will get? This you will get minus 1 whole cube minus 4 into minus 1 minus 9. So what you will get? This is minus 1 plus 4 minus 9, right? So this will be what? This will be minus 6. So it will be minus 6. So if you put 0, it will be minus 9. If you put 1, it will be minus 12. Then if you put 2, it will be minus 9, and if you put 3, it will be 6. Okay. So for 2, for x equal to 2, it is giving a negative value. For x equal to 2, it is giving a negative value, and for x equal to 3, it is giving you a positive value. So since f of 2 is negative, f of 2 is less than 0, and f of 3 is positive, a root lie between. So by intermediate value theorem, what you will get? A root lies between 2 and 3. Therefore, by bisection method, what will be the first approximation? The first approximation will be first approximation to the root is, the first approximation to the root is given by x1 equal to 2 plus 3 by the average of these two roots, 2 plus 3 by 2. What you will get? This is 5 by 2 and this will be 2.5. Okay. Now what you need to find? You need to find the function value at this 2.5. So does f of 2.5, f of 2.5 is 2.5, function is this one, x cube minus 4x minus 9. So it will be 2.5 cube minus 4 into 2.5 minus 9. Okay. So this will give you the value minus 3.375, that is less than 0. Therefore, look at here. So you are getting this function value at 2.5 is negative, and this f of 3, this is positive. So therefore, the root lies between the root lies between 2.5 and 3. Okay, because f of 2.5 is negative and f of 3 is positive. Okay. Therefore, by intermediate value theorem, the root will lie between 2.5 and 3. Next, what you need to check? Now, what will be the second approximation? The second approximation to the root is this will be what? X2 equal to the average of this 2.5 and 3. So it will be 2.5 plus 3 by 2. This will be 2.75. Therefore, now you need to find thus what is the value at f of 2.75. So it is 2.75 whole cube minus 4 into 2.75 then minus 9. Okay. So this will give you value 0.7969, that is greater than 0. So f of 2.5, it was giving us negative value, and here this 2.75 is giving us positive value. So this is positive. So therefore, by intermediate value theorem, our root lies between 2.5 and 2.75. Okay. Therefore, what will be the third approximation? The third approximation is the third approximation to the root is x3 is equal to the average of this two. So it will be 2.5 plus 2.75 by 2. 2.625. So the third approximation to the root is x3 equal to 2.625. Now we need to check what is the function value at this x3. Therefore, f of x3. What is x3? x3 is 2.625. So this will be 2.625 whole cube minus 4 into 2.625 minus 9. So this will give you minus 1.4121, that is negative. Okay. Therefore, a root lies between so see here, f of 2.75 is positive and f of 2.625 is negative. So by intermediate value theorem, a root will lie between 2.625 and 2.75. Okay. Therefore, what will be the fourth approximation? The fourth approximation will be to the root is x4 equal to 2.625 plus 2.75 by 2. So this will give us 2.6875. So we will repeat this process and we will find the successive approximations from x5 onward. So these are the successive approximations. x5 is 2.71875, x6, x7, x8, x9, x10 and x11. So here you look at this x10 and x11. So up to 3 decimal places we are getting the same value, like 2.706, and here also it is 2.706. So hence what we can conclude, hence this x equal to 2.706 is the approximate root, approximate root to the solution up to 3 decimal places. Up to 3 decimal places. So let us look at another example. That is actually, it involves transcendental equations. Previous one, it is algebraic equation. So here, what is given? Let f of x equal to, what is given? Sin x equal to 1 by x. So it will be f of x equal to sin x minus 1 by x. So in the equation, it is given that the approximate root of the equation lies between x equal to 1 and x equal to 1.5. So therefore, what we need to write first, we need to find what is f of 1. So f of 1 will be sin 1 minus 1 by 1, that is 1 only. So sin 1 minus 1. So it will give you minus 0.1584, which is negative. Then we need to check what is f of 1.5. So f of 1.5 will be sin 1.5 minus 1 by 1.5. So this will give you 0.4962, that is greater than 0. Okay, so by bisection method we make a table here. So by bisection method, what we get for x, first one, x1 will be 1 plus 1.5 by 2. Okay, so that is giving us 1.25. Then we need to check the value at 1.25. What is function is giving the value? So f of 1.25 is giving, that is sin x minus 1 by x, that is giving us 0.1862. That is greater than 0, that is positive. So root will lie between, as we know, f of 1 was negative, right? So root will lie between 1 and 1.25 by intermediate value theorem. Next, we need to take these two, average of these two. So next approximation, it will be x2 equal to 1 plus 1.25 by 2. So that is giving us 1.125. Now we need to check what is the function value. So function value will be f of 1.125 is 0.0150, that is positive. So the root will lie between 1, as f of 1 was negative, so 1 and here 1.25, which is positive, so 1 and 1.25, the root will lie between this. So what will be the next approximation? Next approximation will be the average of this one. So this will be 1 plus 1.25 by 2. So this is giving us 1.0625. Now we need to check what is the function value at this point. So function is giving us minus 0.0718. That is negative, right? So now this is negative 1.0625. At this point it is giving negative, and here 1.125 it is giving positive. So the root will lie between 1.0625 where it is giving negative and 1.125 where it is giving positive value. Next approximation will be the average of these two. So likewise we are finding x4, x5, x6 and x7. So for x6 we are getting the root lies between 1.10937, 1.11719. So as the question, in the question it was asked that till 7 stage only you need to find the root. So this is the 7 stage that we are finding the average of these two roots, these two value. So we are getting 1.10937 plus 1.11719 by 2, that is giving us 1.11328. So what will be the answer? Hence the approximate root, hence the approximate root to the solution is 1.x equal to 1.11328 up to 7 stage. So here all these calculations we are calculating in radians. So these are all measured in radians. Okay.
Thank you.